We're now going to use straight lines to model real life situations. So a real life situation could be something like calling a plumber out to repair a pipe. So for example, the plumber would charge you an upfront call-out fee, and then they would charge you an amount of money depending on how much time they had to spend repairing the pipe. So that would be an example of using a straight line to model a real life situation. So in these questions, the y-axis represents the cost. So vertical axis is now the cost. The x-axis represents the time. So horizontal axis is now time. The gradient of any line that we draw or are given is the cost per time. That's what the gradient means. So when you calculate the gradient, you've worked out the cost per time. And the y-intercept of any of these lines is the initial cost. Okay, in other words, the upfront fee or the call-out fee. So let's look at example 1. So example 1 says the cost A and the time taken to repair a washing machine are connected by the straight line equation A equals KT plus D. Now, that equation is very unfamiliar because the equation of a straight line is y equals mx plus c. So in other words, A, which is the cost, replaces y because the cost is on the y-axis. So A has replaced y. T is the time, it's on the horizontal axis, so the x-axis has been replaced by the time. So we've replaced x with t. So that means that k is the gradient. Remember, the gradient is the coefficient of x, but x is now t. So k is the gradient, and plus d is the y-intercept. So we want to get the equation of this straight line, meaning we want to work out k and we want to work out d, the gradient and the y-intercept. So to start off, in part A, we write down the equation that we're given. A equals kt plus d. So A has replaced y. The time t has replaced x. And you know that the coefficient of x is the gradient, so that means k is the gradient. And then plus d is the y-intercept, plus c. Okay. So in order to get the equation, we need to work out what the gradient is, and we need to work out the y-intercept. Now, let's start with the gradient. So the gradient is now k in this particular question. Now, if we look at our straight line, we want to get the gradient. So in order to do it, with two different options open to us, we're going to have to get 2 points that lie in this line. So pick 2 sensible points. So I'm going to go with this point down here. And I'm also going to go with this point up here. So these are the 2 points that I'm going to use to get the gradient. So what I'm going to do is form a right angle triangle between those points. Like that. And what I'm going to use is the rise and run method. So I'm going to work out the rise, I'm going to work out the run. Now you need to be careful, we're not counting big squares because remember there's scales in these axes. So if you take a look at the run here starts at 10 and goes up to 40. So the run is going to be 30. And then the rise, again the rise is not found by counting squares, you need to look at the vertical scale. So the rise starts at 30 and goes right up to 90. So the rise is going to be 60. Now, we're going to use here gradient equals plus rise over run, because the line slopes up, it's got a positive gradient. So, go back to the gradient k. So gradient k is equal to plus the rise over the run again, that's because the line slopes up, so it's got a positive gradient. And then chuck in the rise and the run. So we're chucking in the rise 60 and the run 30. So plus 60 over 30. And that's going to give us 2. So the gradient is 2. Now we've got to work out the y-intercept. So the y-intercept in this particular question is now plus d. So we simply go to the graph and look for where the graph cuts the vertical axis. So the y-intercept here is going to be 10. So all we do now is sub the value of the gradient and the y-intercept into the equation of the straight line that they gave. So our answer is A, so that's the cost in pounds, is equal to 2 multiplied by T plus 10. So the cost in pounds A of repairing a washing machine is equal to 2 multiplied by the time taken to repair it plus this 10 here. Okay, so that's part A. Okay, part B, it says, what does the gradient represent? So we worked out the gradient to be 2. In these questions, the gradient is always the cost per time. Now, the cost is in pounds and the time is in minutes. So the gradient is £2 per minute. Okay. So part B, the gradient, this is the cost per time, i.e. £2 per minute. Because the time is in minutes and the cost is in pounds. So that's the meaning of the gradient. It is the cost per time, the cost is in pounds, and the time is in minutes. So it's £2 per minute. Okay. So every minute spent on repairing the washing machine, it will cost the person £2. Okay, the cost per time. Okay, part C, it says, what does the vertical intercept represent? So the vertical intercept, remember, is plus 10. The vertical intercept is the charge out fee, or the upfront fee. So clearly a plumber here is coming out to fix a washing machine. So where the straight line starts, that is the upfront fee, or the call out fee. So part C, this is the call out fee, or the upfront fee, in other words, £10. So your washing machine's broken down, you need a plumber to come out and fix it, you're going to have to pay them £10 up front to get them to call out, and then they're going to start working on repairing the washing machine, and it's going to cost you £2 every minute that they have to repair the washing machine. Okay. Okay, so part D now is we're just using the equation then to work out unknowns. So it says a man is charged £150, so that's the cost. how much time is spent repairing the washing machine. So we want to work out T. So part D then. So we're going to sub in A equals 150. So remember, A is the cost of fixing the washing machine. So we're going back to the equation now that we have. We're subbing in 150 and we're going to work out how long it took to repair. So we've got 150 is equal to 2t plus 10. And bring our 10 to the other side. So we're going to have 140 is equal to 2t. And then we're going to divide both sides by the coefficient, which is 2. So our 2's cancel, and 2 cancels on the other side, so 140 divided by 2 is just going to give us 70. So answer, T is equal to 70 minutes. So a man's charged £150 for repairing his washing machine. It therefore took 70 minutes for the repair to take place. Okay. Part D. Okay, last one, part A again, something similar. Part E says 100 minutes is spent repairing a washing machine. How much will this cost? So this time in our equation we're going to sub in T equal to 100 and work out the cost A. So sub in T equals 100. So go back to our equation, replace T with 100, so we're going to get A equals 2 upon 100 plus 10. And again, note I'm subbing a number into a formula that has a coefficient, so I have to put brackets around it. There's no powers, there's no brackets with more than one term, so we're going to do our multiplying first here. So that's going to give us 200. And then we're going to add on 10. So we're going to end up with £210. So that is the cost of repairing a washing machine that took 100 minutes to repair.